Hello there and welcome to the series of videos going through the content of A-Level Maths. Here we're looking at the chain rule for differentiation, so we can answer questions from exercise 9c. So the chain rule is a differentiation rule that we use for composite functions. So in this case here, what we've got is the function y equals fg of x. Now, if you remember back to functions, that means the function of f of g of x. So effectively we're doing the g function first and then applying the function f afterwards. So you should see when you're differentiating using the chain rule two functions where one function is inside the other function. And the way you differentiate this is to first differentiate the inside function, so the g function first, or whatever function has happened to the x first, and then times that answer by the differential of the outside function in terms of the inside function. So you differentiate the outside function but keep the inside function inside that function. So you basically differentiate the inside first, then you differentiate the outside second in terms of the second function, in terms of the first function, and multiply the answers together. We're going to see lots of practice at this, so don't worry if it doesn't really make sense at this point here. But basically what you're going to remember is differentiate inside first, differentiate outside second. So, to answer this question here, let's think about what functions we do have. The first function that we have for x is the inside function. The inside function here is 3x to the 4 plus x. And the outside function is the power of 5. So effectively the function is just x to the power of 5. So we'll differentiate the inside function first to get 12x cubed plus 1. And then we'll differentiate the outside function. Now remember, the outside function is just the power of 5, so it's just going to be 5x to the 4. And then let's apply our rules. So it's going to be the differential of the inside first. So dy by dx is going to equal 12x cubed plus 1. Multiply that by the derivative of the outside function, but in terms of the inside function. So we're not going to write just 5x to the 4. We're going to write instead 3x to the 4 plus x to the power of 4, where the inside bit here, the x, has effectively become the g of x function. So it then becomes 5 brackets 3x to the 4 plus x, all to the power of 4. And tidying this all up together, we're going to get 5 brackets 12x cubed plus 1, close brackets, bracket 3x to the 4 plus x to the power of 4. So you can see here we differentiate the inside function first, and we differentiate the outside function second in terms of the inside function. So whatever's inside that function, keep it there, don't move it, but just think about differentiating the power of x to the 5. That becomes 5x to the 4. Okay. So we go at another one. We're now to have a go at sine to the power of 4x. So we've got two functions happening here. We've got the sine function and we've got the power of 4 function. So what I would do is think about it like this. Y equals sine x all to the power of 4. So we can see here obviously that the inside function is sine and the outside function is the power of 4. So differentiate both of them and multiply them back together. So it's going to be cos x multiplied by 4x cubed, but we're not going to write 4x cubed, we're going to write 4 sine cubed, because that was the original function. So the g of x function goes back in as x when we write out our final answer. The stuff in colour here, I wouldn't actually write this down. I'd just go straight to the answer if you're that good. You can just differentiate the inside function. Differential of sine is cos. Differentiate x to the 4, that will be 4x cubed, so 4 sine cubed. Okay, and tidy up your answer so it looks a bit neater. Okay, let's have a go at a question in context now. So given that y equals the square root of 5x squared plus 1, find the gradient at 4, 9, so we'll just differentiate and plug in 4. So first thing we need to do here is write the function differentiable, so 5x squared plus 1 to the power of a half. And then remember the rules of differentiating the inside first, differentiating the outside second. So let's apply the chain rule. Let's differentiate the inside first, so that's just going to be 10x. And then we're going to multiply this by the outside function. Remember, you times the power to the front, reduce the power by 1, and keep the inside function the same. And tidy this up afterwards. Half of 10 is 5x, so we're going to have 5x bracket 5x squared plus 1 all to the then the bracket to the power of minus a half. Substitute in the value of x equals 4 and simplify, and we get 20 over 9. So we can work out the gradient of a graph by differentiating and plugging in the x coordinate. Okay, so differentiate inside first, differentiate outside second. So there's one final rule or quick rule that we're going to have a look at here, and it is the dx by dy rule. So if you've got a function in terms of y, x equals something to do with y, then one thing you can do is do dx by dy instead of dy by dx. So effectively like swapping the letters round. So you're differentiating x function with respect to y. So it's going to become dx by dy, so we've effectively swapped the letters over here, 3y squared plus 1. And then the rule to get back to dy by dx is to do 1 over dx by dy. So now applying 1 over dx by dy, or invert both sides, and you get dy by dx equals 1 over 3y squared plus 1. And we're looking to find the value of dy by dx on the point of the curve 2, 1. So we won't use the 2 coordinate, that's the x coordinate, we'll use the coordinate 1. So substituting in the number y equals 1, and we're going to get a quarter. Okay, so you can swap the letters the other way round. If you've got x in terms of y, then just do dx by dy. Okay, we're going to have 5 different sections of practice questions here then. So the first of them is just going to be an algebraic polynomial expression inside a bracket with a big power on it. Differentiate inside first, differentiate outside second. Pause the video and try these 4 questions out. Okay, let's have a go at the first couple of questions here then. So dy by dx is equal to, differentiate inside first. The inside will differentiate to 5. Differentiate outside second, that's going to be 7x to the 6, but it's going to be 7, 3 plus 5x to the power of 6. So effectively this part here is the outside differentiation, the 5 is the inside differentiation. Multiply the 2 together and we're going to get 35, 3 plus 5x to the power of 6. If you've now got it, pause the video and have a go at the other 3 if you hadn't done so far, otherwise I'm just going to carry on. For the second function, dy by dx, differentiating the inside first, I'm going to get 2. Differentiating the outside second, so I'm going to get minus 3 times by 2x plus 5, so I've times the power to the front. Now I've got to reduce the power by 1, so it's now minus 4. The little dots that I'm using here look like decimal places. I think I'm just preferring to use dots here rather than multiplication symbols, so don't worry about these dots, they are multiplication symbols instead. So tidy up the front, and we're going to get minus 6 brackets 2x plus 5 to the power of minus 4. For the third one, same rule still applies. Differentiate the inside first. Differentiating the inside first is going to get us 10x. Differentiating the outside second, so that's going to give us a half. times by 5x squared plus 3, and reduce the power by 1, so it's going to be minus a half. So in this case here, simplifying this, we're going to get 5x times 5x squared plus 3, all to the power of minus a half. And for the last one, I'll prefer to write this in differentiable form to get started. So it would be 6 times 4 plus 2x to the power of minus a half. And now we can differentiate this. So differentiate the inside first, and we're going to get a 2. Then we're going to multiply this by the derivative of the outside, and that's going to be minus a half times by 4 plus 2x, so times the power to the front, and minus 1 from the power. So it's going to be minus 3 over 2, and simplifying this, it's going to be minus 4 plus... Oh, sorry, I forgot about the 6, haven't I? The 6 needs to go there, so it's going to be minus 6, 4 plus 2x to the minus 3 over 2. Yeah, don't forget about that 6 at the front, that's important. Okay, so those are a range of questions to do with big brackets where we've got a power on the outside. We've got some polynomial expression on the inside. So feel free to have a go at these again. There are some exercises in exercise 9c based on this type of polynomial or equation. But let's have a go at another type of chain rule type differentiation where we've got sine and cos on the outside. So just to remind you, differentiate the inside first and then differentiate the outside second. Pause the video and try these 4 questions out. Okay, so for the first one, dy by dx equals, differentiate the inside first. Derivative of 5x is just 5. And differentiate the outside second. Sine differentiates to cos, but keep the 5x inside. For the second question here, differentiate the inside first. 3x plus 2 differentiates to 3. And differentiate the outside second. That's going to be minus sine 3x plus 2. So the answer here is going to be minus 3 sine 3x plus 2. Do try to simplify once you've got your final answer at the end. Third question, differentiate the inside first. We're going to get 2x, but we've already got 4 at the front, so that's going to be 8x. And then differentiate the outside function, so you're going to get cos of x squared. And the fourth question, dy by dx, differentiate the inside function first, and we're going to get minus 12x cubed. And then this is going to be differentiating the outside function second, so cos differentiates to minus sine, and we keep the inside the same. So in this case here, it's going to be 12x cubed times sine 4 minus 3x to the 4. So there we are, that's how to differentiate cos and sine type questions by the chain rule. Okay, your turn to have a go at the next set of questions, which are E questions. So remember, E differentiates to itself, but remember you've got to differentiate the inside function first, in this case that's the power, and then differentiate the main function of E, which goes to itself. So your turn to have a go at these 4 questions here, then pause the video and try these 4 questions out. Okay, so differentiating the inside function first. In this case, the inside function is the power. So differentiating 4x gives me 4. And differentiating the outside function second. Now, E just differentiates to itself, so nothing much changes there. For the second function, differentiate the inside function first. In this case, that's the power, and we'll just get 3. And then differentiate the main function, which is E, so it's going to be e to the 3x plus 2. The derivative of e stays as e. Okay, third question here then, differentiate the inside function first. That's going to be the power, so that's going to be 2x times by the outside function, which is the e function, and that is e to the x squared. And for the final fourth question, differentiate the inside function first. In this case, that's the power. Differentiating sine gives you cos. And times that by the derivative of the whole function, or the outside function, which is e, and that doesn't change. So you can kind of hopefully spot a pattern here with e derivatives. You differentiate the power, multiply it to the front, so 4, 3, 2x and cos are all the derivatives of the powers. And then the function doesn't change on the outside. It's still going to be e to the x squared, e to the sine x, e to the 3x plus 2, and e to the 4x. So hopefully you've spotted a rule here for e. We've got a couple more sections to go, so now it's ln type derivative. So remember, ln differentiates to 1 over x. But remember, you've got to differentiate the inside function first and then multiply it by the derivative of the outside function. Pause the video and try these 4 questions out. Okay, first question. Now, what you should find here is that a lot of this does simplify. So, differentiate the inside function first. The inside function is 4x. 4x differentiates to 4. And then differentiate the outside function. That will make it 1 over 4x. Remember that the derivative of just a bog standard ln is 1 over x, but when you're differentiating ln 4x and you're differentiating the outside function, it's going to be 1 over 4x, or 1 over gx. And what will happen here is it will cancel out, so you'll just get 1 over x. Now for the second question here, differentiate the inside function first and you're going to get 2x. And then it's going to be differentiating the outside function, which is ln, so that's going to be 1 over x squared. So in this case here we get 2 over x when we simplify. For question number 3, differentiate the inside function first and we're going to get cos. And then times that by the derivative of the outside function, which is 1 over, and it's going to be in terms of sine. So in this case here, this was simplified to cos over sine, which is cot. And for the last question, what we'll do is we'll turn this into a power first. And there are a couple of ways of doing this, but I think my preferred way here is just to apply one of these laws of logs, where we pull the half out to the front, and now effectively we did have a composite function, but now we just have half ln. So sometimes you can simplify these ln ones by using rules of powers. So in this case here, dy by dx is going to equal a half times the derivative of ln, which is just 1 over x. So in this case here, the answer is 1 over 2x. Okay, so there we are. Now, there is a little bit of a rule with the ln derivative ones. What you've seen here is that you differentiate the inside function to get the 4, and then it's over 4x. So effectively what you can say here is it's 4 over 4x. The derivative on the top and the original function on the bottom. Same works here. Derivative would go on the top, 2x. The normal function, the original inside function, will go on the bottom. Same with this one here. The derivative of sine went on the top and the sine went on the bottom. We didn't really see the rule happen here. Now, in general, what you can say is that if you have ln of f of x, you differentiate the inside function first, so that will be f dash of x, and then you times that by the derivative of the outside function, which is 1 over, and it's going to be 1 over f of x. So it's going to be over f of x. So this here is a standard result. Okay, it's one of these ones that you may choose to remember going into an exam that if you have ln of some function, the way you differentiate it, I won't write equals to, but the way you differentiate it is by differentiating the inside, putting it on the top of the fraction, and then putting the original inside function on the bottom. The reason being is that the reason that it creates a fraction is because the ln differentiates to 1 over x, and then when we differentiate the outside function here, it's going to be 1 over, but it's always going to be 1 over your inside function. Okay, so that's the standard rule you may choose to learn, but we've got one more set of videos, one more slide that we'd like to have a look at. Ah, yes, it's like a triple chain rule set of questions here. Don't worry too much, have a go at them. The inside function is quite an easy one, 3x, 4x, 4x, 4x. So as long as you know how to differentiate 4x, you should be okay. Pause the video and try these tricky questions out. Okay then, let's have a go at the first one then. So, same rules still apply. Differentiate the inside function first, then differentiate the outside function second. Differentiating the inside function first will get me 3e to the 3x. And then we're going to times this by the derivative of the outside function, which is cos of e to the 3x. And that's the answer to that question there. Second question, dy by dx. So, derivative of the inside function, now the inside function here is the power, so that's going to be minus 4 sine 4x. And then we'll times this by the outside function derivative, which is e, but e differentiates to itself, so we effectively just keep the e to the cos 4x just there. So the minus 4 part here was created when we differentiated the cos 4x, and remember that will differentiate to minus 4 sine 4x. Question 3. So differentiate the inside function first. That's going to be minus 4 sine, so cos 4x. And then with the ln one, remember that creates a fraction where we have the original function on the bottom. So in this case here it's going to be minus 4 cot 4x. Okay, and the last function here, remember this is going to be a sine to the power of 5, so it's going to be dy by dx. Now the inside function here is sine to the 4x. Because remember, we can effectively write this as sine 4x to the power of 5. So the inside function is sine 4x, which differentiates to 4 cos 4x. And then we differentiate the outside function, which is effectively the power of 5. So we're going to have 5 brackets sine 4x to the power of 4. So 5x to the 4 being the derivative there. And then simplifying this all together, we're going to get 20 cos 4x sine to the power of 4 of 4x. Okay, differentiate inside first, differentiate outside second. But you're going to need loads of practice at this because it does take a long time before you get used to it. So try and answer every question in this exercise. The more you do, the better you're going to be at differentiation. And when it comes to the integration chapter as well, you'll be able to reverse that knowledge much more quicker as well. You need to be doing these questions instantly rather than having to think about them for 5 minutes before having a go at them. So the more you do, the more practice you'll get and the more quicker you're going to get at differentiating all of these functions. So have a go at every question from exercise 9c. Thanks very much for watching this video, and make sure you ask your teacher for help if you need any help on those tricky questions. Don't just stay shy. Yeah, make sure you ask for help if you need it. Anyway, thanks very much for watching this video.